Next topic is solar distillation or desalination of water. As you know, the entire earth, you have like 70% of water and rest 30% actually will be land. Still, the major problem that today's generation, or it has been from, you can say from few decades also, the main problem is the problem of drinking water. Okay, availability of drinking water, and you can say this is the summer time, drinking water or the proper water, that's shortage is going on. So this in this particular solar distillation, now we can't use that 70-80% of the water in the oceans because it is salty. Obviously we cannot drink salt water, but if the salt can be removed from the water, then that particular water can be used to drink. Okay, so in the solar distillation, this is one of we can say old technologies. Okay, that allows the desalination or removal of salt from water. Okay, and you can get fresh drinking water to this particular process. Okay, so in the solar water distillation process includes the use of solar still that separates clean water by the process of vaporization. That means the device used over here is called as solar still. That means you're using the solar energy to desalinate water using a solar still. The name of the device is solar still. Okay, this is a solar still. Here let's see the parts. Actually, this is the sunshade. You can see that is in the shape of inverted V, or you can say kind of a triangle shape. Exactly is that. This is nothing but your glass cover. Okay, this over here is saline water. Okay, this is saline water means obviously it is water that has salt content inside. You have your black surface over here, you have your insulation over here. This is a sand, the sand dune, or it's filled with sand actually, and you have the ambient air, the ground, you have your support. Okay, all these things actually will be there. Now you can see this sunshade covers only half of the portion. Okay, you can see this is glass and this is glass. Half of the glass it covers. So let's see each thing one by one. As you can see in the flat plate air collector, so you had your glass cover, you had your black surface, and you had your insulation. So let me tell you, glass cover, it will allow the sun's rays to be trapped inside. Now the black surface absorbs the sun's rays without reflecting, and insulation does not allow any heat loss. Okay, now here actually what happens is that half of this what we have is or the sun's rays will be falling on this solar still. This entire thing is called a solar still. It will be falling on that. Now the sun's rays come inside and they get trapped over here, and this water, saline water, gets heated. Saline water gets heated, and as you know, the temperature of water to boil is 100 degrees centigrade. At 100 degrees centigrade, the water only and not the salt gets converted from liquid state to gaseous state, and it will come up. It will come exactly, it will rise up. Obviously the gas rises above the liquid, and when it comes above this particular liquid, it gets trapped over here. That means the glass does not allow it to go to the clouds or outside, and it will exactly the gas or the steam what we say, that actually will be trapped over here, or it will touch this glass and it will get converted. And as you can see, this much portion, that is a sunshade. Okay, this much portion is a sunshade. That means here cooling will take place. That means this gas or the steam, that get the water vapor, that gets converted to water due to the coolness provided by the sunshade, and it falls over here. It falls over here. Okay, it falls over here, nothing but this distillate drain. Okay, the water vapor gets converted to water. Okay, and it gets comes over here, distillate drain. That means there is another pipe over here which will collect that water, and the water that you get doesn't have any salt content. It's actually having, or it's actually pure drinking water. Rest of the water vapor whichever is there, again it will come over here, and this particular process will take place. Now the purpose of sand dune, you have to understand that in deserts where there is sand, sand also has a feature of absorbing the sun's rays, and at night time if you are if you keeping your feet on the sand at night time, actually you'll feel warmth, because the sand also has the ability to trap heat, and during night time all it will be giving out heat, so that the people over there they can get warmth. So this is nothing but your solar still. Okay, and you can see the solar still construction, glass cover, as I told you, where the water vapor condensation takes place. Saline water brine body, that means the water that is made that has salt content over here. Okay, salty water. Collector plate or basin liner, where saline water is to absorb the solar radiation. Okay, collector plate is there. Base with insulation to reduce heat loss. Side walls or edges, water container feed, distillate output, vapor leakage, connecting pipes. All these things exactly I have told earlier. Everything of that sort is there over here. Okay, so this same exactly is told, okay, in this over here. You can see in the working also, just now as I told you, or you can read the entire thing. As a transparent glass or plastic cover is tilted at a gently angle of about 10 to 20 degrees, the condensate water droplets that form on the underside of the glass cover collect together, forming large water droplets which gets heavier as they flow and roll down the sloped glass cover into a collector tube or trough at the bottom to drain away the distillate. Same exactly process what I told you earlier. It's explained over here.